You're going to find that today's lesson is nice and easy. Today, we're going to look at 11.6 quadratic regressions. If you remember, we've done linear regressions, we've done exponential regressions. Now we're going to do quadratic regressions. The nice thing is this is like a line of best fit, which means we'll be using our calculators today. So your goal is I will be able to use quadratic regression to fit a curve to the data. So you'll notice in that little example there, you've got the dots almost like in a scatter plot, really close to a parabola, but not exactly. So we're going to find a line of best fit. Now these are the steps you might want to write down or make sure you have in your notes. We're going to start at stat, hit number 1 to edit, and then hit enter. Once you have done that, you will see the L1 and the L2 tables. Remember, L1 was your X values, L2 was your Y values. You will put data into L1 and L2. Make sure they're the same length. If you have 7 L1 numbers, make sure you have 7 L2 numbers. Once you've put your data into L1 and L2, the next step is we hit Stat, we slide over to the right, and we hit Calculate. We've done this many times before, so this should sound kind of familiar. Once you do Stat, slide over to Calculate, then you're going to go down to number 5, quadratic regression. We're looking at quadratics this whole unit, so you're going to hit number 5, quadratic regression, and then hit enter. Now, if you are one that have a newer calculator and you want to store the regression equation in so you don't have to type it later, then you go down to Store Regression Equation, vars, slide over to yvars, enter, enter. But notice my little note over here, this is only if you are solving it or storing it. If you're not up to storing it, then once you hit number 5, quadratic regression, enter, then you go down on your calculator and you press enter, enter, enter. Once you get that done, it'll give you an equation that says y equals ax squared plus bx plus c. It will tell you what the a, the b, and the c are, so you can get the equation. This last little note down here is like super duper important. We're going to use second trace to get that magic table. That's how we're going to get the xy table. So don't forget second trace, which means we will have to go into y equals and type in the equation first, unless you stored it up above. So if you do not store it, that's okay. Once you write the equation, you need to go into y equals and then type in the equation first. So you go to y equals and then you type the equation. I'm going to abbreviate equation with just EQ. This is used for finding the quadratic curve that best represents the data. Kind of like a line of best fit, but for a parabola. So here's what I'd like you to do is take a moment. In your graphing calculators, I would like you to go to Stat, number 1, Edit, and then line up and get your L1, L2s. Remember, the X's are the L1s. So all of these are going to go in list 1. And then all the y values will go in list 2's. So take a moment, get your graphing calculators out, and enter these values. Once you have entered the values, pause the video. Once you're done putting them in, and then you can unpause it. You're going to go to Stat, slide over to Calculate, and then you're going to hit number 5 for quadratic regression. And then if you're storing it, you can go to Store Regression Equation, and you can follow the process of doing enter, enter, enter. If not, that's okay. You will get something that looks like this. It'll say A equals 0.13916859092. Well, we're going to make that easier. We're going to simply say A equals 0.14. B equals 0.81, and C equals 1.27. So I am rounding to the nearest hundredths place value. So once I get those 3 numbers from my calculator, I can write my equation. Y equals 0.14x squared plus 0.81x plus 1.27. That is the regression equation that represents those points that we just put in. So make sure that you're okay using your calculator, following these steps, and then being able to do your enter, 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 and get the equation. Now, let's look at the next one. Take a moment in your calculator. You're going to go back to Stat number 1 to edit. Make sure you highlight L1 and hit Delete, Enter. Highlight L2 and hit Delete, Enter. So pause the video. Your speed is your L1 values, your X values, and your fuel economy is your L2 or your Y values. So pause the video and put those numbers in your calculator. Once you have those values in, you're going to go to Stat, slide over to Calculate, and then you're going to hit number 5 for quadratic regression. Get your X and Y list for L1 and L2. If you're choosing to store, you're going to store regression equation. You're hitting vars, Y vars, and then enter, enter, enter. If not, you're just doing Stat, slide over to Calculate, number 5 quadratic regression, and then go all the way down to Calculate. When you do that, you will see that A is equal to negative 0.008, B is equal to 0.746 if we round, and C is equal to 13.47. So if we want to write our regression equation, we will simply say y equals negative 0.008 x squared plus 0.746x plus 13.47. So now that we have that equation, we want to use it to make a prediction to answer question B. So I'm going to go into y equals on my calculator. I'm going to type in negative 0.008 x squared plus 0.746 x plus 13.47. And yes, I am actually typing this into the calculator as we go. I could graph it, but instead I'm going to hit second graph in order to get my table of values. I want to know what would the fuel economy be if we were going 100 miles per hour. So on the table, I'm going to go to where we find that x is 100. If you look on the table of values, you will see when x is 100, it would be 8.07 miles per gallon. So again, I went to y equals, and I typed in the equation, and then I did second graph to get the table. Then I simply went to where x is 100, or where the speed is 100. And then when I look at that, the y value, the L2, was 8.07 miles per gallon. That's how you're going to use your calculator to do all the work for you in today's lesson. Here's our last example. An object is projected upwards from the ground. The height is estimated in the table below. So you're going to go into Stat, number 1 to edit, clear your L1 and L2 columns, and then take a moment and add this information. Remember, the time in seconds is your X or your L1s. The height is your L2s or your Y values. So make sure you're entering those. Once you have those entered, you're going to go to Stat, slide over to Calculate, number 5, quadratic regressions, and enter, enter, enter to get our calculate, and we will find that A equals negative 12.87. B equals 42.22. And C equals 1.77. So when we go to write that equation, we have y equals negative 12.87x squared plus 42.22x plus 1.77. So let's see what questions we can answer with that information. What would the height of the object be at 3 seconds? Now seconds is our x or our L1s, but notice our table right here did not continue to 3.0. Well, let's do second graph and find our table. Well, you might find that's your table from the previous question, because you need to make sure you go back into y equals and type in the negative 12.87x squared plus 42.22x plus 1.77. Make sure in y equals you have your equation. Now we can hit second graph, and we want to see where it will be at 3 seconds. So when x is 3, y is 12.6. So that says 12.6 feet because we're talking about height. Does that make sense that the height of our object would be at 12.6? It looks like the height's going up, 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 and now it's going down, down. Does it seem reasonable that 12.6 would be the next one? Yes, it does. Because it's continuing the pattern of continuing down until it's going to hit the ground. Then it says, what would the height be at 4 seconds? And if we look at our table, the height at 4 seconds is negative 35.27. Does that make sense that our item would have a negative height? Now, if we're talking about going below water, below sea level, it could be negative. However, we're projecting an object from the ground. So anytime we go up and come down, when we hit 0, we are at the ground. So no, it does not make sense. We cannot have a negative value. So no, we cannot have a negative height. Again, if we were talking about going below water, that's different. That could potentially be negative. However, we're talking about the ground here. So no, we cannot have a negative height. So how are you feeling? Are you comfortable with putting your values into the calculator? If you feel that you're able to put the values into L1, L2, and you're able to follow the directions of stat slide over to calculate, number 5, quadratic regression, and you can use the table to answer questions, then you are good and ready to begin your assignment in class tomorrow.